I asked you to review 2 videos. What were those videos on? Okay, one was on events, and the other? Messages, yeah. So, both of these are important parts of the vocabulary of agent-based modeling, and both of them allow you to implement some very important functionality, which is quite central to most models. So in most models, you're going to see both these sorts of mechanisms. Sending messages being used for what purpose? Sorry? Between agents, or in fact, actually in some cases from the environment to an agent as well. So it's a lot of it is between agents, but sometimes you have other parties communicating to a specific agent. And that's sort of a discrete form of communication. There's other forms of communication that may be in place, or transmission, which might be accomplished via other mechanisms, and soon enough we'll be seeing use of state charts to go between agents. So, stocks and flows to go between agents. So you might have a flow from one agent into another, for example. So that's a form of continuous communication, as it were, a continuous interaction. But messaging is a form of interaction that's discrete in time, and often it interacts with what sort of construct that we've seen. So messages are very naturally tied in with what? What mechanism for describing agent behavior? How do we describe agent behavior? Give me a wave to states, states in a state chart. So transitions within the state chart can be gated based on messages. The transition fires when a message is received, right? And when they're in certain states, agents can further send messages. Send messages while they're in a state, for example, at a certain rate. So very commonly, messages go along with state charts, most notably for communicating between agents as a result of being in a state. Maybe you're in the state of being a satisfied consumer, so you're sharing word of mouth with others around you. You say, oh, this product is good. Maybe you're a person who's communicating with others information. Maybe you're spreading rumors, or you're giving information about the effectiveness of some treatment that you received. Or you are interacting in the form of exposing people to some of your behavior, and you send messages to represent that. So these messages are kind of these discrete packets of information, these discrete forms of communication. They go from one person to another at an instant in time. And they form a key element, therefore, of communication. So messages were one thing that we talked about in the first lecture. How about the second lecture? What mechanism was that about? Events. Okay, so what's an event in this context? Okay. Yeah. Okay, so yeah, it's an incident which occurs at a certain moment in time. And it's no exaggeration to say that events, in a broad sense, lie at the foundation of many types of modeling, and AnyLogic in particular. In fact, there's this type of modeling we'll be learning about called discrete event modeling, which has this essential goal, sort of handling of events. So what's going on in AnyLogic beneath the surface is we have these events occurring at points in time, and these points in time may be irregularly spaced. Maybe they exhibit sort of a punctuated equilibrium where we have long periods between events, and then suddenly a bunch of things happen. This is something which might happen with an accident, or you think about an electrical system going long periods of time delivering electricity, and suddenly there's a bunch of action. You think about rainfall, and you think about flooding occurring sort of in a very brief time. There's a lot of attention to detail during that time. Within a classic system dynamics model, to handle these sort of things, we would need to make the time step of the model very, very fine so that we could handle the as small a level of granularity as we're likely to need, maybe on hours. But in a model which is characterized by these sort of discrete events, we might sometimes have big jumps in when we handle things from one time to another. So this is time along here. And at other times, we handle them in bursts. And there's a lot going on. So AnyLogic beneath the surface is going from event to event to event to event. And these events are of different sorts. Maybe this event here is a, transition event, from a certain state, from state S1 in person A, something like that. Maybe, this other event here is a message send event, something like that, from A to B. These are all timestamped. Maybe, this other event is a arrival event when the agent arrives at some destination. So we have these different types of events. So when I ask you to think about events, there's sort of events in a broader sense, events linked in with transitions, with conditions, with message transmission, starting a model, stopping a model. When the model is just getting started, there's an event associated with agent starting or main starting, and similarly with stopping a model. When an agent is to be destroyed, or when an agent is, or when the model is to be destroyed or to be started, there's events there. And I talk about these as sort of implicit events. Much of AnyLogic interface is geared towards providing you a way to associate code with these events. So you might have code associated with an agent comes into being, you want that agent to store away some information in the database, or load some information in the database, more realistically, load in their characteristics. Or maybe when that agent comes into being, they're connected up in a social network or what have you. Similarly, when the model finishes, maybe you want to dump away some information about what went on during that model run into a database. These are all things which can occur in the context of these events in a model. And AnyLogic, as a tool, provides you huge numbers of different places to tie in with these events. So if you go and you look, for example, at main here, if we were to go take a look at the properties of main, it's going to take a while to swap in, but fundamentally we have some properties associated with coming into being and then getting done. So you'll notice there's all these fields, but the most relevant ones for this purpose are fields associated with startup. So there's startup code and destroy code. That sort of code is handling this event, for starting model or stopping model. And similarly, at the agent level, we're going to have agents who are starting up and stopping. So we have here with person, and person's going to similarly have startup for themselves and destroy. So when a particular person comes into being, whatever code is located here gets invoked, gets fired, and similarly when they're destroyed. Similarly, we saw there's events associated with people's transitions and state charts. We saw that last time. There's handlers associated with them, I should say. So we have all these implicit events which form this kind of textured tapestry that the model goes through and executes over time. And the job of AnyLogic's engine at its most core is sort of servicing these events. What's less clear, ladies and gentlemen, here is that some of these events are contingent upon others. So, for example, the fact that maybe you have a transition here from state S1 to S2, and you have this event scheduled. But if you end up going out you have this transition, an event associated with this transition scheduled, it's down on the schedule. And if you go out via a different transition, this event gets descheduled. Or suppose this agent dies before this transition occurs. Suppose this agent dies due to some other cause or due to them reaching a certain age. This event will need to be descheduled. So there's this whole interaction between the event scheduler, the scheduling of particular events, adding them to the schedule, and removing them from the schedule if they're preempted. In other words, if they're overridden by another event occurring, they can disappear. So AnyLogic has a quite sophisticated scheduler here, which allows for handling sort of the classic SD case with fixed time steps, but it allows for much more general sort of situations. So we have these events. Now so in the context of this general notion of event, ladies and gentlemen, what is an event in the sense that we have an event, a reified event object? What is this? This event here. What's that event object that we add in? What job does it serve? So we add this in, say, to main. What job does that event serve? That reified thing called an event.
Once it's conditions for firing on the event, then it fires.
Good. Does it represent just one event in here? Or a repeating set of events. It could be a set of events which are occurring at a regular fixed time interval after a certain timeout with a recurrence time. Or it could be an event that's occurring with a certain rate, a hazard rate, a chance per unit time it will fire off. Once per day, this event on average fires. So we can associate it with that. These events which are added to the model in terms of formally explicit events. So here we can explicitly declare events. And why do we do that? Why do we declare these sort of events within our model? Why would we want to have an event firing the model? After all, there's millions of events going on beneath the surface, often in a model. Why would we want to add an explicit event object? What benefit would that have?
Maybe clearer.
Okay.
For somebody who's reviewing code, but beyond that, it's going to be an event that happens outside of the control, perhaps, of an agent.
Okay, but I guess I'm probably asking something you're presupposing. When this event goes off, it fires, what happens? Okay, the code associated with it. So what's going on is that we want to add these events so that certain code is run at certain intervals or certain frequency or with a certain rate or what have you. So that's why we add these events. We want to run code. We want to run code at certain times. We may want to have an event which runs code every month because we want to do reporting on a monthly basis on some statistics. We may want to have code that runs at a certain rate because we want once a day, say, person to, on average, once a day, someone to come in and join the population as an immigrant. We may want to have an event that runs on a timeout basis at a certain time. When that event fires, we change something in the model that changes the behavior of the model. These are all reasons we might want to have an event, okay? An explicit event in our model. We add to our model an explicit event shown up there as the first of us. So ladies and gentlemen, that's good. We want to run this code. We want things to happen. Why the second of these? Why a dynamic event? Let me ask this. It's a slightly trick question. The first of these, is it dynamic? In what sense is it dynamic or not dynamic? Sorry? Ah. Beautiful. Beautiful. Yes, you've hit it on the head. The first of these, you know, when I talk about this, I feel a bit schizophrenic because half my brain is like thinking about modeling. In modeling terminology, this is dynamic. This is dynamic. It's a thing over time. The events firing over time. So sure, why is it not dynamic? The other side of my head, from a terminology and software engineering and to some degree in broader computer science, I would say no, this first one is not dynamic because its characteristics are determined statically. They're determined, you know, the times that it fires or its schedule for firing is determined when I build the model. It's determined when I specify the model. It's not truly dynamic in the sense that it gets determined on the fly. It gets determined sort of as the model's operating when it occurs. It's pre-scheduled. Beautiful term. Excellent. So that's great. So that's sort of a distinction between the two. So a dynamic event is an especially flexible sort of event. If I were the creators of AnyLogic, I would have called this a flexible event or something like that, or a flexibly scheduled or dynamically scheduled event would be the best way to put it, probably. Dynamically scheduled event. The idea is that we have some sort of event template which we can use to create events at runtime. We use it while the model's running. We can use it to schedule an event. In contrast to this situation, the top event, where we know ahead of time, oh, this is going to fire every month, you know, for 10 years, or it's going to fire on average once a day for 5 years. Here, what we're actually doing to schedule it, it's in code. It's actually something that determines, well, if this thing happens, then we'll create an event. And that event will go off some period of time from now. I'll record that, it will go off, and then it will be done. So this dynamic event describes sort of a template that we use to create specific events over time, and we'll dynamically schedule them in the sense that the conditions will come about during the program operation. We may wish to schedule these or not. Okay, so this is a very useful concept. Now, how is a dynamic event different in what it requires you to specify than is the first type of event? So a dynamic event. So we've seen there's a bunch of different types of events, event subtleties, but I talk about a dynamic event. How is a dynamic event different in terms of what it requires to specify? Yeah, required parameters. So there's certain information that's needed for it to then be scheduled. And critically, ladies and gentlemen, critically, when it goes off, it has access to that information. So the information, when it gets added as an event, that information is squirreled away. It's remembered. And so when it finally fires, it has access to all this information that was provided from when it was created. So, you know, I gave some examples in here, I think. So specifying a dynamic event, we could drag it from here. The important thing is that this is specifying sort of a template for these sort of events. In this case, they're deer bursts of deer. And this deer birth, it gets some information. So when you say schedule me a deer birth, you have to specify certain information. what information needs to be scheduled? What? Well, for example, if the deer that's going to be born is female or male, that might be something we schedule. But more importantly, sort of we might say, oh, what its sort of genetic sequence will be. Where did the conception occur? Where did the mating occur between the male and the female that led to this birth down the road? All this information is saved away, so that when I schedule that birth to occur 9 months from now, I can't remember how long is Kurt. You may remember. You're the only one I know in here who's talk with Maria. How long is a gestation of a deer? I think it's like 6 months. Maybe it's 8 months or something. In any case, the deer's mate, and then this gets scheduled. This information gets provided, and then later, when the action occurs, when the code occurs, all that information is available to it. So when the job actually has to be done, create this new baby deer, it knows all the information it needs to kind of create itself. It knows, oh, I'm a female, whether or not I'm a female, what's my genotype, where did I get conceived. That's all things that it's remembered away when I schedule this event. And I might schedule this event many, many times. Okay, another deer is also scheduled to be born at a different time, and that remembers different information. So each time, I want to schedule this thing well ahead of time. It's like you enroll and you schedule ahead of time when you'll finish or something like that. Here it's scheduling this, but that's something that's dynamic. We can't pre-specify when deer will be born because we don't know when the mating's going to occur and where it will occur and so on. Instead, when the mating event occurs, we call this, it saves it away, and then 6 months later, when the gestation is finished, the deer is created using that information that's stored away. How many people in here have seen the beauty of closures? Okay, no, my heart goes out to you. How many people have seen closures that just don't think they're beautiful? Okay, no one. Okay, closures are a way to wrap up information with a function so that when the function actually is called, it knows a lot of information already. So it knows the information it needs to do its job. It just has to be called later. And I'm not going to go into that now, but basically this is kind of similar. It has all the information it needs to do its job, so when it fires, it just does its job because it saved away the requisite information from when it got started. So one of my students, for example, used this sort of mechanism very helpfully, simulating people getting born in Saskatchewan. She had a number of people that had to be born a certain year, but she had to distribute them all through the year. So all she did is use a dynamic event, and she basically, at January 1st, she scheduled their entry into the population, their births, or what have you, all through the year. So some are going to be born a month from now, some are 5 months from now, some 2 days from now. She pre-scheduled all of that, so she had a whole bunch of these dynamic events all ready to go, and when each of them happened, it knew all the information it needed to add the person to the population with the right characteristics. So even though she had a list of how many people would be born in the entire year, she ended up turning into a whole bunch of dynamic events distributed throughout the year with the appropriate distribution. Okay, so these are dynamic events, and I mentioned those two cases. Okay, so dynamic events. They're quite useful. They're used a lot less than, in my experience, than a static event. Or than a normal event type, statically scheduled event, and but they are useful when they're needed. So that was a brief recap of some of the videos. So what questions do you folks have right now on